let's look at a couple examples of parabolas in their standard conic section format. Okay, so in this first example, we have the graph of a parabola. It opens downwards, and it looks like it passes through the point 4, -2. Okay, so the standard equation, the standard conic equation for a parabola opening vertically, so in this case it's opening down, which would be oriented vertically, the standard equation is x squared is equal to 4py. And that should look similar to what you would see in like a pre-calc algebra class. If you had a parabola opening upwards, you'd have y equals x squared. And if it opened downwards, you'd have y equals a negative x squared. So that hopefully should kind of make sense. We're having y is equal to x squared. And the 4p part of the expression, that just kind of describes or helps determine for us how wide the parabola is going to be and how sharp of a curvature it's going to have. And whether it's positive or negative determines whether it's going to open in the positive direction, which would be up, or in the negative direction, which would be down. So to actually write the equation that corresponds to our graph, we need to figure out the value of p. And in this case, we can do that because we don't know where the focus or the directrix are, but we do know, or we can assume that we have a point on the graph that's at 4, -2. So if I plug in 4 for x and a -2 for y, I'll have 4 squared is equal to 4p times a -2. Well, I know 4 squared is 16, and 4 times a -2 would be a -8. So I have 16 is equal to a -8p. And if I divide both sides by -8, I will get p is equal to a -2. Okay, so because the 2 is negative, because the p-value is negative, that tells me that the parabola will open in the negative direction. So since it's oriented vertically, it will open down. Okay, and it also tells me, if we just look at the absolute value of p, so just a 2 in this case, it tells me the distance from the vertex of the parabola, which is at the origin, to the location of the focus, and also to the location of the directrix. Okay. Remember that the focus is always inside the parabola. So in this case, since the parabola curves downwards, the focus is going to be down below the vertex, and the directrix is always outside the parabola. The parabola curves away from the directrix around the focus. So it's going to, since it's curving down, the focus has to be below the vertex, and the directrix has to be above the vertex. Okay, and the distance between all of those, so the distance from the vertex to the directrix or focus is the value of p. Okay, so if my vertex is at the origin for this graph, and I know the value of p is 2, then I know the distance from the vertex to the focus is 2, and it's actually 2 units down, right? Because it's actually a -2, and it's also 2 units up from the focus to the directrix. Okay. So if my vertex is at the origin, then my focus is going to be 2 units below the origin, so that's at 0, -2. And my directrix is 2 units above, and remember, a directrix is a line, either horizontal or vertical. And so we want to write it as the equation of a horizontal or vertical line. In this case, it's a horizontal line, so we would have y is equal to 2. Now, the last part here that we need is the focal diameter. The focal diameter is the width of the parabola passing through the focus point. So since the focus point's at 0, -2, we want to look at the distance or the width of the parabola where it crosses y equals a -2. So that would be the points 4, -4, -2, and +4, -2. And so the distance from a -4 to a +4 is 8. And so our focal diameter is going to be an 8. Now, if you notice, that 8 turns out to be, well, we're going to see here in a second, that focal diameter is what's going to be in front of the y variable. We didn't actually finish our equation. So to finish that equation, let me take that p-value of a -2 and plug it in for the p in our equation. So x squared is equal to 4 times a -2 times y. And so that means we're going to have x squared is equal to a -8 times y. So that's what the standard equation would look like. X squared is equal to a -8 times y. And the 8 that's in our equation, that corresponds to the length of the focal diameter. So in general, the focal diameter, you could think of as being as the absolute value of 4 times p. Okay, so it's going to be whatever number's in front of the linear variable. In this case, that's in front of y, and we don't need to worry about whether it's positive or negative. So the focal diameter is going to be an 8. All right, let's look at another example. This time we're given the equation of the parabola y squared equals 20x. And we basically want to do the same thing. We want to figure out the focus, the directrix, and the focal diameter. And this time we want to sketch its graph. Okay. So let's start with, let's figuring out the value of p, because once we know p, we can figure out the 3 key characteristics. So the standard equation for a parabola is y squared equals 4p times x. Okay, so it's very similar to the equation we saw before, but it's y squared instead of x squared. And so if we look at our standard equation here, 4px, that 4p has to correspond to the 20 that's in our given equation. So y squared equals 20x versus y squared equals 4p times x. So that means if we connect those together, we'll have 4p is equal to 20. If we divide both sides by 4, we will get that p is equal to 5. Okay, so now that we know that p is equal to 5, we know that the parabola has to open in the positive direction because 5 is positive, the p is positive. And we also know the direction that it's going to open. Because it's a y squared, it has to be a horizontally oriented ellipse. So it either has to open to the left or to the right. But again, because p is positive, because we have that positive 5, which came from the positive 20, we know the graph has to open in the positive direction. So since it's horizontal in the positive direction, that would correspond to being to the right. So the parabola has to open to the right. And we know the vertex is at the origin. So let's sort of start working on a little bit of a graph. And as we're working on the graph, we can also work on finding the other values here. So we know that we have a parabola, its vertex is at the origin, and it's going to open to the right, which means, again, remember the parabola curves away from the directrix and around the focus. So if it's curving to the right, that means the focus has to be to the right because it's curving around the focus. And if it's opening to the right, that means it's opening away from the directrix, which means the directrix has to be to the left. So we're going to have this parabola opening to the right. We have a focus that's inside the parabola, so it's to the right, and we have a directrix that's to the left. So since the graph opens horizontally, the directrix is now going to be perpendicular to that. It's going to be a vertical line. Okay, we just need to figure out where those are and then the focal diameter. So let's start with the focus. Remember, the distance from the focus to the vertex is measured by p. And since the vertex is at the origin and we're moving 5 units to the right, the focus is going to be at the coordinates 5, 0. And then the directrix. So remember, the directrix is the same distance, but now to the left. So 5 units to the left would be at a -5. And so if we go a -5, and again, it's a vertical line. So vertical lines are written as x equals. So we're going to have x equals a -5 for the directrix. And then the last piece that we need here before we finish our graph is the focal diameter. And we saw in the last example, the focal diameter we could think of as the absolute value of 4p, which if we look at the graph, the 4p was equal to 20, or positive 20. We don't need the sign there. So 4p is equal to 20, which means the focal diameter is equal to 20. And remember, the focal diameter is the width of the parabola using a diameter that passes through the focus. So that means from the focus, if you traveled up to the top and then down to the bottom, that total distance is 20, which means the distance from the focus up is 10 and distance from the focus down is also 10. So we could actually figure out where these points are on the graph. So the one above the focus would be at 5, 10, because again, that's 10 units above the focus. And the coordinate below would be at 5, negative 10, because again, that's 10 units down from the focus. And the distance from 5, 10 to 5, negative 10 is a distance of 20, which is what our focal diameter is supposed to be.